Hello everyone and welcome back to AMOS, our course on agile methods and open source. We are now in the final set of slides for our software development and quality assurance in agile methods like Scrum and extreme programming. An important movement almost that has come out of agile methods is the focus on rapid delivery and ultimately what's now being called continuous delivery, making sure that any software you're developing gets put into use and thereby produces feedback that helps steering and management of the project as fast as possible. And this is an incredibly important thing specifically for the software industry, because in comparison with other, say, more hardware-oriented products, continuous delivery, as we will discuss it, is a set of techniques and a culture as well that makes you go from an innovation, the new piece of code that implements something innovative, to that product doing its job out there with a customer or with customers in a market in minutes. No product so far that I'm aware of has had such short time span from being implemented to being used to generating the feedback that helps us steer the management or steer a project. Or if you have classic hardware, that's half a year cycle or a year of time that goes by before you actually get any feedback from a market. With continuous delivery, we can get feedback almost within minutes. But let me get to that now in steps. So here's how it looks like if you're a beginning software developer. You learn a programming language, you edit your source code, you compile, and you keep editing until the software builds. Actually compiles, the compiler doesn't complain any longer, and the software builds. Once it builds, you may try to run it probably, and as you test it, you do so by hand. So you play with the software, check whether what you just implemented does its job, and if you're satisfied, then you deploy it, put it into production, which probably here means something like submitting your homework as a student of computer science. Now, you typically quickly evolve from this very basic edit, compile, run cycle to a slightly more elaborate one, where there is a real production system, and B, there probably is something like a configuration management or versioning system in between that lets you keep track of the many different artifacts, files of your project. So you have edit, compile, build cycle where you run the software and test it, probably locally on your machine. And if you're satisfied, you commit. And from that code repository, you have defined, you commit to a code repository. And from that code repository, you have defined versions, releases that you can check out, build, and deploy to a production. And once deployed to production, you can actually operate your software, meaning you still need to administer it. So the important thing here is to understand that at some point of time in your life, you realize the difference in environments in which you're working. One is your own workstation, and another one is the production system, where independently of your laptop, the software does its job. I'm quite sure everyone who realized that distinction also learned this the hard way by the development environment and the production system being set up in different ways, making bugs or problems appear in the production system that just weren't there in the development environment. So it's driven home pretty quickly to each developer that you need a uniform and consistent environment that's the same for your development machine as it is for your production system. We realized that a development environment and a production system is usually not enough. Professionals clearly have a test system in between. So the process of software development is one where developer works in his or her own environment, tests the software there, and eventually commits to a code repository, from which then the software is fetched and built and deployed for testing purposes on this test system. And this testing can be automated, it can be done by hand. Traditionally, it would be QA engineers who would build the software for the test system, and where they would check and test the system either by hand or by automated scripts, something like it. And if they concluded, if the QA department inside a company, which is typically separate in classical software environment, development environments or shops, different from the development environment, then the QA system would give the green light for a release, which would mean that the software would be deployed to production, where it would be operated and monitored for proper operation. So this is the professional setup with a development environment, a test system or a test environment, and the final production system. Now enter all the work that has come up with agile methods, specifically more automation in the process of testing. So here, while already in a professional development setup, there could be automated testing, certainly by QA for the test system. With agile methods and the solution of the difference between engineering and quality assurance departments, there is now test automation for both within development and the test system, meaning you write automated test code that you can run as a developer before you decide to commit, and which you can run again as a test engineer or quality assurance engineer as part of the testing procedure on the test system. These tests, this is what are fully automated. And continuous integration then adds yet another step, which is not only are there fully automated tests, there is an automated trigger for these automated tests. So as soon as a developer commits to a code repository, there is actually an automated test process being triggered with feedback being provided as to whether the software does its job. And after test automation, and there's still though by hand sign-off in this model by test engineers, quality assurance engineers who make a release decision of the software to production. This is actually where, this is where agile methods come in. Test automation, of course, existed long before, but let me repeat it. Test automation here is simply the automated execution, human independent execution of as large as reasonably possible number of tests for the various different types of tests that we shortly touched upon earlier in this course, for component tests, acceptance tests, and integration tests, with the purpose, of course, to provide feedback on the quality of the code base to quality assurance. Now, continuous integration, to add to that, is the extension of that process by automatically triggering it. Technically, we really simply have post-commit hooks, meaning triggers from the code repository that start a build process, a fetch and build process, which trigger a running or execution of the tests, etc., to provide that feedback to developers and managers. The purpose is to always know where you're standing, to make it as short as possible, a time distance difference between your significant change of something, here commit to a code repository, and the status update of the system, the code is still running properly. This implies also that in order for continuous integration to work, you actually need to take a test-driven software development approach. Historically, as a kind of humorous tidbit, this all developed over the last 10, 15 years. Historically, to give developers this key feedback, people would hook up lava lamps to a build server where through some interface, USB interface probably these days, though this is probably not really in use any longer. Lava lamps would be triggered. A nicely bubbling green lava lamp would indicate that the last build succeeded and the tests all ran, while the red bubbling lava lamp would indicate that, oh no, there is a test failure. Well, this humorous historic note leads me to the more modern way of displaying this information in the form of dashboards. Probably these days most people are familiar with continuous integration dashboards, which will give you more than just this binary information of green or red, but give you much more information along the lines of this is the component breakdown of the system. All of these components are green, but except for that one component which is red because there's a failing test. So let's managers drill in the status information on the system quite nicely. All right, so here you can see one example of such a dashboard. Jenkins, of course, perhaps the most well-known open source one. And you can see how it's displaying the results of the build number 437, and the tests that were run here, no failures, which of course is very nice to indicate everything seems to be green. Such a dashboard has quickly developed to not just, these dashboards have quickly developed to not just present information on like last build and test runs, but provide many more information about the systems. You can hook up all kind of metrics tools these days, which let you investigate the quality of the code base independently of the test runs, etc. So they become a pretty broad dashboard to generate insight into the system from an engineering management perspective. You can dig into most of this information in more detail here. Some test results are being looked at in detail. After continuous integration, there was actually yet further steps to take, because in continuous integration, that final deployment step was still a human decision, where developers or QA engineers would say, well, it all is green, but we are not ready yet, and would make an explicit separate decision, maybe close to release deadline, to release the source code now. With continuous deployment, we are now talking about this continuous integration, code integration process, and also automatically deploying it to production. So you can see how this process from the development environment through the test system to a production system gets fully automated in continuous deployment. And this only could possibly work, of course, if there's strong test automation and good test coverage, and B, there are proper ways of monitoring and possibly rolling back the software that has been put into production. This is really something where your engineering organization needs to be pretty advanced. Not many are doing it. Those who are doing it often develop custom monitoring software. We're talking metaphorically here about an immune system that will reject bad deployment. It's an active area of research in my research group, and certainly something that is not at all yet well understood, but clearly an ambitious goal, because, as I said in the opening words to this segment, where we want to go is to, as fast as possible, feedback from real users without, of course, annoying them so much that they will not return. So we need to go from the initial innovation, the development work, to putting it to good use in a production system as fast as we can. But if something goes wrong, then we need to pull back and be able to pull back either by hand or automatically. And that's tricky because while you might argue, well, let's just write more tests, you will never know where these mistakes are coming from. My favorite is that may want you to pull back some deployed software. My favorite example is something so out of left field that no test would usually be able to capture it unless you know the particular failure, and then of course you can always write a test for it, which is like you're building a web shop and you are deploying a system into production based on the latest commit, which just looked really fine, passed all tests, everything's good, but nobody's buying any longer. Oh no. Well, so obviously your web shop is not doing its job, and it's not a real programming error, but in this example, the buy button was by typo or whatever mistake changed in color from black to white, text on white background. So users don't even see the buy button any longer, something that is really hard for a test to capture. It is, however, and that's where the interest in immune systems as monitoring, health monitoring, if you will, software comes into play, which is you could define key metrics for the operations of your system. And if these metrics, which should be orthogonal to your tests, if these metrics indicate a worsening of the situation, then possibly roll back to the last known good commit. So you could be establishing key metrics like average hourly sales and roll back code if somehow your sales go down beyond what you would consider within a realm of statistical probability, indicating some serious failure that was not caught by your tests. All right, so you want to fully automate that as far as you can, but also put safeguards in place that let you catch some of the failures or problems that automated tests will not catch, which again is quite an active area of research. Continuous delivery, so let me summarize that, is a delivery process where upon a trigger, the commit to the official code repository, the whole process is triggered and executes all the way to a full deployment to production. You should ideally have a monitoring layer in place that rolls back a bad deployment. And again, the purpose is gathering feedback as fast as possible for the purposes of not getting the innovation out. So for the purpose of getting the innovation out as fast as possible to do its job, recoup your your investment into development, but also to gather the feedback that the development team needs to do its job fast and better. This is really a development where things feel like they've been speeding up over time in software development. We had test automation for a long time. We eventually got continuous integration, where what was once considered costly builds were just automated and triggered all the time. And now we have continuous deployment where companies really put code into production right away, all the way from the initial commit by a developer. It builds on each other. Test automation was just tests and testing in an automated way. Continuous integration added to this the style of development, test-driven development, continuous deployment added to that, the deployment to production, possibly, not always, but possibly with a monitoring and rollback. And yet another term, DevOps, developer operations, added to that, a culture of engagement, including availability by developers on the weekend, not its most liked feature, but something that certainly disciplines development. So DevOps added that cultural layer. Which is what I wanted to communicate. This is an active area of research. Continuous delivery as the main headline these days comprises these 4 major components: test automation, continuous integration and deployment, and the cultural change that development operations is bringing us. That's it. Thank you very much, and see you next time.